Hello guys, welcome to another section of Math. Let's look at how we can evaluate this definite integral here using partial fractions. Well, maybe we can try other approaches, but here we are going to use partial fractions to evaluate this definite integrals. The evaluate here simply means after we are done integrating, we have to find what the actual value, we have to find what the value. That is why that is why we are having this 0 and the 1 here, or that is why it's a definite what integral. So without wasting much time, let's get started. But first, let's write our solution. Now let's break this integral down here. Alright, integral will be going from 0 to 1, that is 2x plus 1 divided by x minus 2, and then to bracket x squared plus 1 dx. This problem here, looking at the nature of it, well, I don't know, maybe you can express it in the form of integration apart, maybe whereby you have to multiply, open the bracket for the whole of this, and then apply the negative index law and write it as the whole of this raised to the power minus 1 times this one. Then you apply integration apart to solve it, or maybe you make use substitution and then you do cancellation and then you solve. I don't know how, but as I said, we are going to use what partial fraction approach to solve this question here. Okay, so what we are going to do here is here we are going to apply the partial fraction directly from here. We're not going to do any substitution, any other thing else. We're not going to do anything. We're just going to apply the approach directly from here. Okay, so what we are going to do in the next step is that you're going to split it. Looking at the nature of the denominator, that is this and that, we can split it using the partial fractions. Provided if the denominator was maybe in a quadratic or polynomial form, we could have first factorized what the denominator, or we could factorize the denominator to this form, and then we apply a partial fraction. But lucky for us, the denominator is already in this form. But how is the partial fraction going to be applied? Because there are three ways of using the partial fractions. We have one, the linear factor, where the problem is linear. Two, quadratic factor. Three, and then repeated factor. When you say it is linear factor, it means that the denominator, all of them, or those in the bracket, are not having any square in it, or even if the denominator is in quadratic form, then you factorize. You're not going to get anything like square in any of the numbers and the variables. That will be in what? The parentheses. Okay, that means when it happens like that, we say it is what? Linear form. And also, the quadratic form also simply means that after factorizing, those that remains in the bracket, you will still see some of them having square on them, as this one is what reflecting. After factorizing, maybe I don't know how, or maybe when you multiply this by this, it could have given you x cube. But after factorizing that particular expression, we have gotten x squared plus what? 1. So because of this x squared plus 1, it has made this what? problem here what? A quadratic what? Factor. That means if you want to apply the partial fraction, we have to use what? The quadratic factor what? Approach. And then the repeated factor simply means that let's assume that this one is x minus let's say 2, and then here is x, let's say plus 1, and then you have another one which will be having something like x plus 1 squared, or something like x minus 2. Then in this bracket you see x plus 1, and then x plus 1 all raised to the power what? 2, or all squared, or x plus 1 into bracket raised to the power what? 2. That means instead of the power 2 being on one of the variables, it is rather in the bracket, and the whole of that bracket is what? Raised to what? Power 2. That means instead of 2 being here, the 2 will rather be written at the back, at the top here. When you see something like that, we call it what? Repeated factor. There are ways of dealing with them in terms of what? Applying the partial fraction. But our problem here, after from the what I just said, you could see that they are how the partial fraction is going to be applied will be based on what? The quadratic factor approach, because we are having what? The square here. Okay, so we are going to apply the quadratic factor approach to solve what? This one. So let's split it using what? The partial fractions. Not just any partial fraction, the quadratic factor approach. Alright, so let's split it. Okay, with the quadratic factor approach, when you want to apply the partial fraction using the quadratic factor approach, with linear factor, you could see that all of the numerators are what? Just let's say a single what? Letters or single variables like a, b, c, something like that. But with quadratic factor, because of this x squared here, you could see that we are going to get something like what? Of this nature, that is a over x minus 2 plus bx plus c divided by x squared plus 1. Okay, so anytime you see any single fraction where the denominator is containing what? Maybe squared after factorizing, and you are to apply the partial fraction approach, that is how you are going to go by. Anytime you see the quadratic approach, you see square after factorization in one of the brackets, it means to apply the partial fraction, you apply what? The quadratic factor approach. And that is how the quadratic factor approach. This is how the quadratic factor approach works. Okay, so those without any exponent on them, we just put a on. Assuming if this one is here and then this one is here, this place could have been ax plus b, and then if this one is here, this one will just be what? C. Where the quadratic factor is where we attach what? The s, but normally we write them according to what? Letters of the alphabet. Since this one is fair, this one will go for a, and then this one is the next one, so we should have write b. The next letter is what? From a move on to b, but because of this quadratic factor here, we've what? Added what? X. Okay, so it has become bx plus c. Bx plus c. So that is how the quadratic factor approach is used in terms of what? Partial fractions. Okay, so what we are going to do here is that we are going to find the value of what? The numerator, that is the value of a, b, and then what? C. As for x, is the same thing as one of the variables x here. So when we are computing, whatever maybe we change this x, it will affect the change. Any changes that we make here will affect this s also. So we just leave it as it. The most important thing to focus on is to how to find A, B, and then what? C. Okay. So how are you going to find A, B, and then C? Well, to do that, we are first going to form a linear equation from both expressions. That is 2x plus 1 divided by x minus 2 into bracket x squared plus 1 will be equal to, now we find the LCM for this one also. That is, this will multiply, sorry, this will multiply this, and then the whole of this will also multiply this, and then we multiply the new denominator, that is this and this together. So we are going to get 2x plus 1 all over x minus 2x squared plus 1 is equal to a into bracket x squared plus 1 plus into bracket bs plus c multiplied by into bracket x minus what? X minus 2 divided by x minus 2 x squared plus 1. So when you look at it from this way, you could see that both left and right hand side will be having on the same denominators. Then we multiply through by x minus 2 times x squared plus 1. When we do that, on the left hand side it will be left with 2x plus 1, and on the right hand side it will be left with what? X a into bracket x squared plus 1, and then plus into bracket bx plus c multiplied by x minus 2. Okay, so that's how the equation which is going to be reflected here is arrived. So let's first using the cover up rule method, 2x plus 1 is equal to a into bracket x squared plus 1 plus b into bracket bs plus c multiplied by into bracket x minus 2. Now we are using, there are two approaches in finding the value of what? The numerators. Either you use the expanded form approach or what? The cover up rule approach. So here we are using what? The cover up rule. The cover up rule means we eliminate some, then we find some. So either we choose to eliminate the whole of this one is a product, so if we eliminate this, then we find A, or we eliminate this, then we find maybe one of the variables here, or we can choose to eliminate this and then find this. Who knows? It depends. Okay, so first we are going to put using the cover up rule, we are going to find the value of A, B, and then C. But to do that, we're just going to put x equal to certain numbers. I mean, any number that can help in eliminating either A or the whole of this, and then we leave this one so that we can work on it, or maybe eliminate the whole of this and then give us some answer to this, and then help us find the value of what? A at the end of the day. Okay, so we're going to put A is equal to, now when you are choosing the numbers, to be on the safer side, just check the equation on the right hand side. Here, when you put x is equal to 1, it will never eliminate anything. Okay, but when you put x equal to, let's say 5, we're just increasing your problem. So to find out which number should I put x to, just check your equation. Here, when you put x equal to minus 1, it won't work. But when you put x equal to 0, yeah, it might work. B will go, it will left with C, and then there was A. And also when you put x equal to positive 2, you could see that here we are having x minus 2. So when x is equal to positive 2, this place will be 0. And the whole of this multiplied by 0 will be what? 0. And when you place x with positive 2 here, you're going to get what? 4. 4 plus 1 give us what? 5. That means when you put a is equal, x is equal to positive 2, this one will be eliminated and to be left with what? This one. Okay, that is a into bracket x square plus what? 1. Then we work on it and then we find the value of what? A. Okay, so first let's put x equal to positive 2. Now, wherever you see x from here, from this linear equation, we're going to put x equal to what? 2 there. Okay, so let's replace x with 2. You're going to get 2 into bracket 2 plus 1 is equal to a into bracket. Now when you square 2, you're going to get 4 plus 1. And then here bx and the s is 2. You're going to get 2b plus c. And then here is 2 minus what? 2. Now 2 minus 2 is 0. 0 times c is 0. 2b times what? 0 is what? 0. So all of this place will be what? 0. Now let's come here. Here will give us what? 4 plus 1 will give us 5. 5 times a will give us what? 5a. Here 2 times 2 will give us 4. 4 plus 1 will give us what? 5. So you're going to get 5 is equal to 5a. 5 is equal to 5a. So what is the value of a? A is equal to what? 1. When we divide both sides by 5, you're going to get a is equal to 1. A is equal to 1. Now we've gotten the value for what? A, but we are not done. Left with what? B and then C. Okay, next, what are you going to do? Well, let's put a, from the original equation, when you put x is equal to 0, you could see that on the other part, on the right hand side, on the right hand side, we are having bx plus c. So when you put x equal to 0, you can see that b will go away and you left with what? C. Okay, and already we have gotten the value of what? A here. So whatever equation that we get, we just replace a with 1 and then we find the value of what? The other variable. Okay, so let's put x equal to 0 into your original equation again. Let's see what we will get. Good. Now when you put x equal to 0 to the original equation again, that is how it's going to look like. Now here, this times 0 will give us 0, so here we'll be left with 1. Here we'll be left with a. Now this time this will be 0, and it will be left with what? C. It will be left with what? C. Now 0 minus 2 will give us what? Minus 2. So minus 2 times c will give us what? Minus 2c. So you're gonna get 1 is equal to a minus 2c. 1 is equal to a minus 2c. But here we can find the value of c because we know that a is equal to what? 1. We know that a is equal to what? 1. So let's replace this a with what? This one here. Okay, so a is equal to, but a is equal to 1. So let's replace a with 1. So you're going to get 1 is equal to 1 minus 2c. 1 minus 2c. How are we going to find the value of c? Now, you bring this one here. So 1 minus 1 will be 0. Minus 2c is equal to 0. 0 is equal to minus 2c. When we divide both sides by minus 2, you're going to get c is equal to 0. C is equal to 0. Okay, you see, after putting s equal to certain variables, we have managed to get the value for what? A, and also the value for what? C. It has left with what? B. Okay, so now when we put x equal to any number apart from 2 and then 0, though you get a, b, and then c forming a linear equation, but that won't be a problem because we know the value for what? A, and also know the value for what? C. So in our next step, to find b, we're going to put x equal to what? 1. We're going to put x equal to 1 into the original equation again. So let's put x equal to 1 into the original equation again, and let's see what we are going to get. Now when x equal to 1, or when you place it to the original equation, this is what you are going to get. 2 by 1 plus 1, and then a into bracket 1 plus 1 plus b. I just wrote b there because b times 1 will give us what? B plus c, and here having 1 minus what? 2. Okay, here will give us what? 2 by this one give us 2. 2 plus 1 will give us what? 3. So on this left hand side we are going to get 3 here. Now when we come here, 1 plus 1 give us 2. 2 times this one give us what? 2a. Now let's come here. 1 minus 2 give us what? Minus 1. Now when you multiply b by minus, you're gonna get minus b. This one 2 by minus 1 give us what? Minus c. So we are going to get 3 is equal to 2a minus b minus what? C. Good. Now this equation is very simple to solve because we know the value for a. We also know the value for what? C. We have already solved them or worked for them. Okay, so a is equal to 1 and then c is equal to 0. So we just put them here and then it will be left with b. Then we send we group like terms, then we find the value of what? B. So a is equal to 1 and then c is equal to 0. So let's put replace c with 0 and then replace a with what? This 1 here. Now 3 is equal to, when we do that, 2 by 1 will give us what? 2, and then when we place c with 0, this is how it's going to look like. So 3 is equal to 2 minus b minus 0. Now minus 0, no, it will not do us any good because so we just ignore it. Now let's put our focus here. 3 is equal to 2 minus b. How do we get the value for what? B. Well, either we bring b to this side and then send this one to this side. This is going to be the same. You're going to get the same answer. So 3, we just subtract this one from this and we are going to get positive 1. So 1 is equal to minus b and minus b is equal to 1. So we divide both sides by what? Minus 1, and that will give us b is equal to minus 1. Okay, so now that we know the value for each of the variables in the integral, let's replace those variables with what? The values that we had for them. Okay, so you're going to replace a with 1, b with minus 1, and then c with what? 0. And then let's see what we are going to get and then we integrate. This one, bear in mind that you don't bear in mind that you not change what the limit of the integral because we haven't made any what substitution. Okay, we just split them, so we are still in the same world. We haven't do anything. Okay, or we haven't done anything rather. Okay, so don't bother changing the limit of what the integral. Just leave it as it is too because we are still in what? The x world. Okay, here it was a, but we know that a is equal to 1. So when you come here to 1 over x minus 2, and then here it was bx plus c. C is equal to 0, and then b is equal to minus 1. So minus 1 times x plus 0 give us what? Minus x. So that is how come this was minus is here. So here I'm gonna get x over x squared plus 1. Or dx. Now, after splitting into partial fractions, the integration has now become what? Easier to what? Solve. So here we're just going to integrate directly without doing what? Anything. Well, we can easily write the answer for this one and also for this one as well. So there's no need for us to what? Split them again. Okay, this one you're going to split it into two separate integral or two different integral, whereby it will be 1 over x minus 2 dx minus x over x squared plus 1 dx. No, we can write answer for this one, and you can also write answer for what this one. Okay, so we are not going to um split them before we solve. So here we're just, the next step, we're just going to write answers for each of the fractions here in terms of what integrating. Now when you integrate this one, you're just going to get you already know natural log absolute value of what x minus 2, x minus 2. And you know why? It's because when you make substitution for this one, u is equal to x minus 2 and then differentiate, du be equal to what dx. Okay, so when you come back to into the integral, we are having 1 minus what 2, and 1 minus u will give us what, when you integrate, you're gonna get natural log absolute value of what u, and u is equal to what, u is equal to x minus 2. So the answer to this integral is what, natural log absolute value of what, x minus 2. Okay, minus, now let's integrate this one also. Now here here I said we can easily write the answer, because if I want to show you the working, I'm not going to show you, but it's very simple, but I'm not going to work it out here. I'll just say it and then we write the answer. Okay, so this one, when you make the derivative of the whole of this, can eliminate this one. So u is equal to x squared plus 1. So when you differentiate, you're gonna get du is equal to 2x, dx is equal to du over 2x, and that x will cancel out with this x here, and to be left with what, 2. So when you replace them back into the integral, you're gonna get 1 over u times 1 out of 2 du. Now when you integrate, you're gonna get 1 over 2 natural log absolute value of what, u. But what is u? Yeah, here I use u and I'm using u here again. Don't worry. Yeah, when yours, make sure you use another variable, but I'm sorry for that. Maybe what is u? Maybe this one is u different, not the same u that you do. The u here was, let's say, u, and then the u here is, let's say, u2. Maybe full stop. Yeah, u full stop. Let me say something like that, so that it will be different from this one. Yeah. So when you come here, you're gonna get 1 over 2 natural log absolute value of what, u full stop. Wow, what is u full stop? You don't mind me. What is u full stop? U full stop is what, x squared plus 1. So we just replace u full stop with what, x squared plus 1, and you're going to get, so when you integrate this, you're going to get 1 over 2 natural log absolute value of x squared plus 1. So this one will give us natural log absolute value of what, x minus 2 minus 1 over 2 natural log absolute value of what, x squared plus what, 1. Yeah, you don't worry why this limit here is not reflecting on this side and this side. You don't worry. We're just going to, in the next step, we're just going to put them into this expression, and then we find the what value at the end of the day, because the question says we should evaluate. Okay, so answer to this one is this, and answer to this one is what, this um this one here. And then what is next? We are done with the integration. The next step is to what, find the value of what, this expression here, by putting in what, the value of what, or x here, that is what the limit given, that is going from 0 to what, 1. And you know that to find the value of what, a definite integral, the formula is always what, upper limit minus the lower limit. What is the upper limit? The one on top here. Lower limit is the one what, down here. So we are going to put this one into the whole of this, and then we subtract after putting 0 into this one. Whatever we get, we subtract from what, when we put 1 into this, whatever that we are going to get. Okay, so first let's put 1 into this one, and then later on then you put this one into this one, but make sure you subtract your what answer. You subtract your what answers, okay? Because the formula is upper limit minus what the lower limit. Anytime you want to what evaluate or find the value of what an integral, or after integrating you want to find the value, just put the upper limit into the expression. Whatever you get, just subtract the low after putting the lower limit into the also expression. Whatever you get, just subtract it from what the value you had after putting the upper limit into the hot expression. So first, let's replace what the upper limit. Okay, as I said, you subtract. Good. Now, when you put 1 into the whole of this is what you are going to get. X is equal to what? 1. So when you come here, you just put 1 here. That is natural log absolute value of 1 minus 2 minus 1 over 2 natural log absolute value of what? 1 plus 1. So let's finish with this side. This side will give us what? Now this one will give us minus 1. Minus 1. Now, natural log absolute value of what? Minus 1 give us 0. Yeah, it will give us what? 0. You punch it on your calculator. You take your calculator and then you punch it. Absolute natural log absolute value of 1 will give you what? You see, it could give you it will give you what? 0. So this one will give us 0. And then when we come here, it's minus. That when you come here is 1 plus 1, and that will give us what? 2. So natural log absolute value of what? 2 give us what? I think the same as 2. But here we don't need the absolute value again, because we have come to know that um 1 plus 1 is what? A positive. 1 plus 1 give us what? A positive answer. So there is no need for what? Absolute what? Value. Absolute value is normally taken when we don't know whether x is positive or what? Negative. Okay. So even this one we could have just because the limit here, none of them is what? Negative. But just that from the integral, from the loss of the integral, when you integrate something like that, we always take what? Absolute what? Value. Okay, so here we are going to get minus 1 over 2 natural log of 2. And then when you come here, natural log absolute value of 0 minus 2 give us what? Minus 2. Now, natural log absolute value of minus 2, when you finish it on your calculus, are going to get what? Natural log of 2. Natural log of 2. This minus this will give you what? Minus 2. But when you take the absolute value of that minus 2, when you point the whole of natural log absolute value of minus 2 on your calculus, you're gonna get what? Natural log of 2. Natural log of what? 2. Natural log of what? 2. The absolute value is sometimes positive and what? Negative. So if we are having s to be minus 2, well, it's rather positive and negative. So it's what? Positive here. Good. So when you find it on your calculus, you can see that it will give you what? Natural log of 2. Natural log of 2. Now let's come here. 1 plus 0 will give us what? 0. And natural log absolute value of what? Oh, sorry. 1 plus 0 will give us 1, and natural log absolute value of 1 will give us what? 0. Okay, so this side will be 0, and then also this side will be 0. So the answer to this one will be minus 1 over 2 natural log of 2. And then when you open the bracket, you see this times this will give us what? Negative. But this one is rather what? 0, so you will not consider it. So you're gonna get 1 minus 1 over 2 natural log of 2 minus natural log of what? 2. Good. So as I said, minus 1 over 2 natural log of 2 minus natural log of what? 2. Here, this and this are the same, so that means we can subtract what their coefficient. And subtract their coefficient. What is their coefficient? Here is what? -1, and this one too is what? -half. So minus half minus 1 give us what? That is 2 by -1 give us what? -2. -2 minus 1 will give us what? -3. So we are going to, when you compute this, you are going to get -3/2 natural log of 2. -3/2 natural log of what? 2. So the value of that definite integral is what? -3/2 natural log of what? 2. 2. 2. All right, so let's conclude. Therefore, this one is therefore the value of this integral is equal to what? -3/2 natural log of what? 2. This one, you will not add any plus c because it is a definite what? Integral. With definite integral, we know we know the what? Value, but with indefinite integral, we don't know any what? Value. That is why we add what? The constant to it. But this one, we have solve for the value of what? The answer to that integral at the end of the day. So there will be no plus c. With definite integrals, we don't add any plus what? C. The plus c only comes when it's what? In the free. That is where after you are done integrating, just add your plus. You don't put any x equal to or any theta is equal to blah 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 to find any numerical what? Value. Okay, so this one we will not add our plus c to it. So this integral here is equal to -3/2 natural log of what? 2. 2. 2. Yeah. All right. That's it, guys. Please, if you like this video, kindly give it a thumbs up, subscribe, and comment. Thanks for watching.